Okay, so we're looking at just a revision video that you might use to get ready for the test coming up on surface area and volume. And again, just a reminder, the volume, we could define it as the cross-sectional area times the length. So the cross-sectional area is the face that doesn't change. So when we did, for instance, again, when we did a cube, the face that doesn't change is a square, and then we times it by how long it is. So we've talked about that before. So any shape that has a constant shape, we can just multiply the cross-sectional area by how long it is, and we find the volume. So just be ready, like on your cheat sheet, just include any shape. So, cube is a square. But again, you need to just look at the formulas for parallelograms and trapezoids, just so you've got it on your cheat sheet in case you need it. Okay, so let's look at surface area. So that was volume that we're talking about there. The volume is the cross-sectional area times the length. But when you've got surface area, it's what you can see, and sometimes I call it what you can paint around the shape. And the trick is with composite shapes, you've always got something that's hidden that you can't actually see, and you need to account for that. And whether you subtract it or just don't use it in the formula, that's up to you how you do it. Okay, so let's look at some examples. Okay, so we're going to do a couple of examples each, like it's not going to be comprehensive. So I want you to pause the tape, and when you're ready, come back live. In this first one, we're doing surface area and volume for both. In subsequent ones, we'll just be doing surface area or volume. Okay, so pause, and when you're ready, come back. Okay, so the first shape is a cuboid. We'll do the volume first because that's easy. That's LWH. So we've just got 6 by 3 by 1. So the answer is 18, and we're in volume, so the units are cubed. Surface area, we've got 2 LWLH WH. So we've got 2 lots of 6 3s are 18, 6 1s are 6, 3 1s are 3, 16, 18, 24, 27, 2 times 27. So the answer is 54, and area, the units are square units. So again, if by chance there's no units, then if there was no units given, you just say 18 units cubed or 54 units squared. So you cover your bases if the unit is not included in the diagram. So it's a cubic unit, you don't know what the unit is, or it's a square unit. But in this particular case, we knew. Okay, so the next one, we'll do volume first because that's always a bit easier. Pi r squared h, pi times 2 squared times the height is 4. So 2 squared is 4, 4 4s are 16. So the answer is 16 pi. And then you just use your calculator to work out that as a decimal. So 16 times pi. So the answer to one decimal place is 50.2. We're doing volume, so it's cubic units. But that answer is the exact answer. And then obviously you can use decimal places. Okay? So you can have the answer of 16 pi, or you can calculate it as decimal, depending on what the question is asking you to do. Surface area, I'm going to use the short version, 2 pi r plus h, because it is a little bit quicker. So 2 times pi times the radius is 2, and then 2 plus 4. So 2 plus 4 is 6, 2 times 2 is 4, 4 6 are 24. So the answer is exactly 24 pi, and then if you want to do a decimal, that would give you 75.4 to one decimal place meters squared. Okay, so you can have exact answers or you can do decimal places. It just depends on what the question's asking, it'll say. Okay, let's moving on. Okay, so these ones here, these are composite shapes. This one's a dodgy diagram, but what I've got is 3/4 of a cylinder because I've got a right angle there. But if you've got an angle, like just remember there's 360 degrees in a circle. So if there's an angle given, you just put whatever the angle is on top, and that equals the fraction of the circle. Okay, so that fraction is 3/4, but if you were given the angle, then you just put the angle over 360 because there's 360 degrees. Okay, so have a go. We're only doing volume, we're not doing surface area, so it should be nice and quick. Okay, you may or may not be back. I'm going to call that 1, I'm going to call that 2, and we need to have some dimensions. Okay, so if that's 2 and the total's 6, then that's a 4. If that's 1 and that's 2, then that's a 3. And it's going by 3 each time. So volume 1 is 2 by 2 by 3. 2 by 2 by 3, which is 12. Don't need to put the units in yet. The volume 2 is a 4 by 3 by 3, equals 36. And so the total volume is 48, and the units are cubic units. Okay, next one, the volume of a normal cylinder is pi r squared h, and then we just put the 3/4 out the front. Okay, because we've got 3/4 of a circle, so that means we've got 3/4 of a cylinder, and we're only doing volume, so we don't have to worry about the faces. Okay, so let's have a go. So it's 3/4 times pi times the radius is 3 squared, and the height is, and I didn't give a height. That makes it hard. That was a bad thing I did. Okay, so you will have noticed that by now. Okay, so 0.75 times pi times 90. So that answers 202.1, correct to 1 decimal place, centimetres cubed. So look, sorry about that. You obviously couldn't do it without the heights, but there it is now. Okay, moving on. Okay, so this one here, I just want the surface area. The volume is straightforward. So we've got a triangular prism, but you're going to have to use Pythagoras to find the missing side, and have a go when you're ready. Okay, so let's put this information. So that's 4. If that's 3 and that's 6, then that's 3. And again, you should recognise that that side will be 5 because it's a Pythagorean triad, or you just use Pythagoras. Okay, so we'll call that shape 1 and we'll call that shape 2. So surface area 1. Okay, so we've got the bottom shape is a 4 by 2 by 3. So surface area equals 2 times 4 2s are 8s plus 4 3s are 12 plus 2 3s are 6. So we've got 26. So at the moment we've got 52, but there is a hidden shape. We can, some classes may not do it that way, but I'll subtract the hidden at the end. So surface area 2 is base times height, which is the triangle front and back. And then we have 2. And we can, in my formula, I just say multiply by all the lengths. And again, we've got a hidden face, so we'll subtract that at the end. So that's 12. So we've got 12 plus 24 equals 36. So the total surface area equals shape 1 plus shape 2 minus the hidden faces. Now, that face is the hidden face, and it's hidden on both the top and the bottom. So I subtract it twice, and that face is a 4 by 2. So again, it depends on the class. I do it as a hidden face, and there's 2 hidden faces, one the top and one the bottom. So 52 plus 36. 4 2s are 8, 2s are 16, so the answer is 72 metres squared. Okay, moving on. Okay, so this is second last page. A can has a radius of 4 and a height of 12, and these are the word questions where you've got to actually find the surface area or the volume and then do something with them. Okay, so this gives you a clue that we're measuring area, and this gives you a clue that we're going to have to find the volume and then turn it into capacity. Okay, so have a go when you're ready, come back. Okay, so the surface area is 2 pi r plus h, which is 2 times pi times the radius is 4 times 4 plus height is 12. Now don't forget, your classes might have learnt it as 2 pi r squared plus 2 pi rh, and you get the same answer, so don't be too worried if you're not using my version. So we've got 2 4s are 8 times 16 times pi. So that's 402.12 centimetres squared. And then each of those centimetres squared is going to be multiplied by 5 cents. It's expensive can, isn't it? So take that, multiply by 5, and you get 2010.6 cents, which is $20.11. Okay, so we just have to round up that last one. So it's $20.11, or we could have 2011 cents, but you can't have 0.6 of a cent in your rounding. Okay, so next one is a volume question. So the volume formula is pi r squared h, but we've only got half of it. So either divide by 2 or times by half. So it doesn't matter which you do. Radius is still 4, and the height is 12. So technically, you could have changed, instead of having height of 12, you could have had the height of 6. So rather than doing half of 12, you could have had it as a 6. Okay, so a half times, not a half, so pi times radius squared times 6, and then you've got half your height. So it doesn't matter which way you do it. So 0.5 times 16 times 12 times pi equals 301.6 centimeters cubed, and then that would be 301.6 milliliters. Once you've got centimeters cubed, you automatically have milliliters. Okay, I think we've got one more question to go. Okay, this one's one that hopefully you've all practiced. There will be questions like this where you have to design a shape that has a volume of 10, and you're not told what shape to use, so you can use anything you like. You can use a cube, a cuboid, a cylinder, etc., etc. It doesn't matter which you do, but I'll just show you a couple of ways of doing it. Okay, so have a go yourself, and when you're ready, come back live. Okay, so let's see what you could have done. So if you had a cube, so the volume equals length cubed, so 10 equals length cubed, so L equals the cube root of 10, and on your calculator, the cube root of 10 is 2.154 centimeters. So that could have been a cube. If you had a cuboid, any combinations of numbers that multiply to 10. So it could have been 5 times 2 times 1. It could have been 1 times 1 times 10. It could have been a half times 1 times 20. It could be any of those combinations. If you were going to get complicated and have a cylinder, so you got pi r squared h. So 10 equals pi r squared h. So r squared h is 10 over pi. So you just got to play with the numbers. Let the radius, let's go back a step. So if the radius was 1, so you got 10 equals pi times 1 squared times height. So height equals 10 over pi times 1, which is just 10 over pi. So the height would be 3.183 centimeters. So the radius is 1 centimeter and the height is that, and you got your volume of 10. So you can freewheel and work out what sort of complicated shape you want to do. Okay, that is it. Hopefully you've got something out of it. See you later.